Cardiovascular diseases are the leading cause of morbidity and mortality worldwide. It has been shown that various disturbances of fetal development may contribute to development of cardiovascular disorders in the adulthood. Additionally, epidemiological studies show that female and male patients suffering from cardiovascular disease exhibit different responses to diverse recommended treatments. The molecular basis underlying these sex-specific differences is still not well understood. On top of everything mentioned, dysregulated activity of sympathetic nervous system is a hallmark of numerous cardiovascular disorders. Considering these findings, we were interested in the effects of prenatal stress on cardiac expression of several molecules that modulate activity of sympathetic nervous system. We applied stress protocol to pregnant rat females that could potentially mimic everyday life stress that pregnant women are exposed to. 3-month-old pregnant female blister rats were subjected to a chronic unpredictable mild stress protocol that included a random and intermittent exposure to a variety of stressors during the 3rd week of gestation. The offspring were sacrificed by decapitation at 2 months of age. Total RNA was isolated from the basal and apical portion of the left ventricles and used to generate cDNA for quantitative real-time PCR. The relative gene expression levels for beta 1, 2, and 3 adrenergic receptor as well as monoamine oxidase A were determined by comparative delta-delta CT quantification method. We showed that beta 1 and 2 adrenergic receptor genes exerted sex and region-specific expression pattern in left ventricular rat myocardium. Our results show that in offspring from unstressed mothers, beta 1 adrenergic receptor is predominantly expressed subtype in left ventricular myocardium in females. Same was observed in apical region in males, while basal myocardium exhibited similar beta 1 and beta 2 adrenergic receptor mRNA levels. Beta 3 adrenergic receptor mRNA was undetectable in the tissue. We detected decreased apical beta 1 and a trend of increase in apical beta 2 adrenergic receptor mRNA levels in prenatally stressed females, which consequently resulted in the loss of differential beta adrenergic receptor subtype expression levels at the apical myocardium. Altogether, these results indicate that prenatal stress differently affected beta 1 and beta 2 adrenergic receptor populations at the apical myocardium of female offspring. In contrast, prenatal stress did not have comparable effect in male offspring. Furthermore, our results showed that prenatal stress did not significantly affect monoamine oxidase A mRNA expression at neither apical nor basal region of left ventricle in female and male offspring. However, the basal myocardium of male offspring showed trend towards higher relative expression of monoamine oxidase A compared to basal myocardium as well as compared to female offspring. Results from our study may point out the factors contributing to sex-specific differences in development, prognosis, and outcome of cardiovascular disorders. Care should be taken when making the decision about the potential treatment involving modulators of sympathetic activity among female and male patients suffering from cardiovascular diseases. The mechanism for decreased apical myocardial adrenergic receptor beta 1 mRNA expression in prenatally stressed female but not male offspring is unknown. Based on available literature, we hypothesized that sex hormones might have an effect. It would be of interest to investigate earlier developmental stages of prenatally stressed offspring. Furthermore, we did not compare cardiac expression levels of monoamine oxidase A between male and female offspring. However, based on the relative expression levels of monoamine oxidase A, we can hypothesize that our results suggest that cardiac monoamine oxidase A exhibits a sex-dimorphic gene expression pattern, which is likely expressed more abundantly in the heart of male rats than in female rats. Whether these changes correlate with diminished cardiac performance and predispose organisms to develop cardiovascular diseases during their lifetime remains to be determined in future experiments.